So exponents and division. If we have the problem, x to the 6th, y to the 4th, z to the 3rd, divided by x squared, y, z. When in doubt, write it out. Because one of our objectives, Jordan, please face the front. One of our objectives is to expand, to write out our problems. So instead of the numerator of this fraction, instead of the top, saying x to the 6th, y to the 4th, z to the 3rd, I could write it down as x, 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 x. There are 6 x's. Then there are 4 y's. And there are 3 z's. That's my numerator. That's what x to the 6th, y to the 4th, z to the 3rd looks like. And then I can do the same thing for the denominator, the bottom. Instead of x squared, I'd put x times x. Instead of y, oh, that doesn't change. I just put y. And then z. Now, some students are going to like to line up their variables. So some students are going to write it like this. Put the y underneath the y's and the z underneath the z's. It doesn't matter which way you do it. But if I look at it now, if this was a number, if this was, instead of x, if this said 9 divided by 9, if they're the same thing, what happens? They cancel out. What happens here? They cancel out. Anything else cancel out? A y and a y cancel out. Because y divided by y, that disappears. And z divided by z disappears. So if I'm going to write my answer, my solution, I canceled those out, I canceled those out, I canceled, they disappeared. But what's left over? X to the 4th. 1, 2, 3, 4. What else?
Y to the 3rd.
1, 2, 3. So y to the 3rd.
Z squared.
And z to the power of 2, or z squared. So when in doubt, if it does not make sense, you can expand it, write it out, and cross out what cancels out, our inverses. Or you can follow the rule. If the powers have the same base, if the powers have the same base, what do you do to the exponents? Subtract. Subtract the exponents. 6 minus 2, because x and x are the same base, 6 minus 2 is 4. 4 minus, what's the exponent down here with the y? 1. 4 minus 1 is 3. Z and z are the same base. 3 minus 1 is 2. If the powers have the same base, subtract the exponents. Drew and Declan, please stop interacting with each other. So let's try a different problem. If I have 6a to the 4th over 2a. 6a to the 4th over 2a.
That row in this room, you know the name? D-E-T-H.
Breath hour?
Breath hour? Yeah.
She was in here last year.
Last year. Okay. All right.
Okay, so again, when in doubt, write it out. So my top is going to say 6A, A. Drew, you need to turn around. This is the last time I'm going to tell you. Over 2A. I'm using the same concept. If it's in the numerator and the denominator, if they're the same, I can cross it out. However, these problems have coefficients. So we should simplify the coefficients. What's 6 divided by 2? 3. 6 divided by 2 is 3. And what's left over for my variables? A to the 3rd. So this exponent rule, if the powers have coefficients, right? 6 is a coefficient, 2 is a coefficient. Coefficients are the numbers in front of a variable. Simplify first. So maybe what if it was 2 over 6? What would 2 over 6 simplify to?
Something in the decimals.
1/3. If it said 10 over 5, you'd simplify 10 over 5 to 2. If it said 3 over 6, you'd simplify 3 over 6 to 1/2. If the powers have coefficients, simplify first. There's something you need to remember. If the exponent is a 0, you know what, hold on. We're going to do this first. All right. What if you had the problem 4x to the 4th over 10x to the 4th? So let's simplify first. 4 over 10 simplifies to what? 2 over 5. X to the 4th over x to the 4th. Let's subtract. 4 minus 4 is x to the 0. Ladies and gentlemen, do you know what happens if you have 0 as an exponent? It's 1. There can be no 0. So it's 2 to the 5th times 1. Because x to the 0, a 0 exponent changes the answer automatically to 1. Watch. 5 to the power of 0 is 1. 16 to the power of 0 is 1. Negative 2 to the power of 0 is 1. Anything with an exponent of 0 is 1. So what's 2/5 times 1? 2/5. If the exponent is 0, if the exponent is 0, it equals 1. The whole thing disappears and you just put the number 1. Last problem, or last rule. So if the powers have the same base, you subtract the exponents. If the powers have coefficients, simplify first, then subtract. If you ever get an exponent that's 0, remember, just remove it and make the whole thing into 1. You can't have negative exponents. For example, (16x to the 3rd, y to the 10th) and 2x, y to the 18th. All right, let's do our rules first. Let's simplify 16 over 2. 8. You could say 8 over 1, that's fine. All right, let's do the x's. 3 minus 1 makes x squared. And y to the 10th divided by y to the 18th is y to the negative 8. Now, I just told you you can't have negative exponents, right? All right, so let's do our rule. When in doubt, write it out. It's going to take a lot. 16, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over 2x 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Whew. Now if I look and I start crossing out, I start simplifying, I start using my inverses. 16 over 2 is 8, so I was right with that. I cross out my x's, and I'm left with x squared, that's right. I cross out my y's, and I'm left with 1, 2, 3, 4, 5, 6, 7, 8. But I got a negative 8. What do you think a negative 8 means?
I don't know.
Where is it left over? Look at it. Where are those y's?
They're on one side of the plate.
They're on the bottom. A negative exponent means you take that power and move it to the bottom. So this answer is not 8x squared y to the negative 8. it's 8x squared. And where's y to the negative 8 going to go? I'm going to put y to the 8 on bottom.
That's the answer.
Because there are 8 y's, but they're on the bottom. So if the power has a negative exponent, move it to the, what's a better word than bottom? Denominator. If you subtract and get a negative number, a negative exponent, right? Like 10 minus 18 was negative 8. If you get a negative exponent, move that power to the denominator, because you cannot have negative exponents.
Follow, Chief. The mattress.
Guess what?